Okay, we are going to use the rational root theorem. We're going to use it to factor a polynomial. And we're going to start with a polynomial that factors out with all of their zeros being real whole numbers. So we're going to keep it basic, but then we're going to increase the difficulty as we do more and more problems with the rational root theorem. So I have a 4-step process that I like to use. We're going to identify some information. We're going to do 4 steps. And in those 4 steps, either your problem is complete or you have to repeat those 4 steps. But either way, you only need to learn those 4 steps. You either do it once, sometimes twice, sometimes multiple times. So let's keep it basic. Let's see a problem that we can do doing my 4-step process one time through. All right, so first thing that we want to do is just identify information that we're going to use in those 4 steps. So the information that we want is going to come from your leading term and your constant term. So this is the lead. This is your constant. All right, so over here on the right, we're going to say leading coefficient. Let's see, on my x cubed, I have a leading coefficient of 1. That says lead. All right, then our constant is the next thing that we need to know. And in this case, our constant is 20. And another thing that we're going to talk a little bit about, but we'll go more in depth later, is our lead degree. All right, so the degree is 3. That tells us that there should be 3 factors. We'll talk more about why that's true at a later point. But it's nice to look at now. It's a way just to check our kind of final answer. All right, so our lead coefficient, our constant, and our degree are the information that we need to identify so that we can do this 4-step process. So let's talk through that. So step 1. Step 1 is to list possible rational roots using that rational root theorem. So we're going to list possible rational roots. So again, this only makes a list of the possible rational roots. We're going to use that rational root theorem, which means we need to utilize plus or minus p over q. All right, so plus or minus p over q. So p is your factors of constant. Q is the factors of your lead coefficient. So we have a list, plus or minus. All right, our constant here is 20. So what are the factors of 20? 1, 2, 4, 5, 10, and 20. All right. So those are all numbers that evenly divide into 20. So they're the factors of 20. All right, factors of the lead coefficient. Well, the lead coefficient is 1, so that's nice. It only has one factor, 1. So we are going to create our list. So our list looks like this. Plus or minus 1, because we're dividing each one by 1. Plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, also known as positive or negative. of each of those. Okay, so step 1, done. We made our list. So, if there are any doubles, we could reduce those out. If there are no doubles, then our list is what it is. We'll see doubles a little later on. All right, step 2. We need to test our list with synthetic division. So step 2. So we need to test that list because those are possibles. We don't know which ones are real. So we need to test them. So we're going to test the list with synthetic division. All right, when you test the list with synthetic division, we're using the factor theorem. And the whole point of this is synthetic division has this really neat process on it that if the remainder is 0, then the term that you divided by is an actual 0 for that polynomial, which creates a factor. So that's what we're looking for. We're testing to find zeros. So if the remainder is 0, then we can go, yay! All right, then yes, we have a 0, which can create a factor. All right, so let's do that. We have 1, 2, 3, 4, 5, 6, and a positive and negative of both of them. So we have 12 numbers to test. You're not going to test all 12 of them. You're only going to test the list until you find a 0. And then we're going to pause. We're going to kind of reset from there. All right, so let's start testing. So we are going to start with positive and negative 1. So we are using x cubed minus 8x squared plus 11x plus 20. All right, that is what we're dividing. We're going to start with positive 1 and negative 1. So we're going to test 1, and we're going to test negative 1, and hope that one of those gives us a 0. If not, we're going to move on. So let's see, our coefficients in our polynomial is 1, negative 8, positive 11, positive 20. So 1, negative 8, positive 11, positive 20. All right, so let's begin that synthetic process. Always drop down your first coefficient. Then we're going to multiply up and combine down. So 1 times 1 is 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. Combine that together, I still have 4. 1 times 4 is 4. Combine those together, we have 24. Is that a 0? No. Okay, we're looking for zeros. All right, so let's try negative 1. Drop down my 1. 1 times negative 1 is negative 1. Negative 8 minus 1 is negative 9. Negative 1 times negative 9 is a positive 9. 11 plus 9 is 20. Negative 1 times 20 is negative 20. Oh, look at that. 20 minus 20 is 0. What are we looking for? We are looking for zeros. Yay! And you take a sigh of relief because you found one. Okay. So, if x equaling negative 1 causes a 0, then we have a factor of x minus negative 1, or x plus 1. So, step 3. So once you find one, you stop your testing process and you identify what you have. So step 3, we are going to rewrite with factors. So the factors that we found. So we're writing factored form, but we're not necessarily done. So let's see. We have a couple pieces of information. In step 2, we identified this. Since x equaling -1 is a 0, then x plus 1 is a factor. All right, and then we also need to take this answer to synthetic division. We got to deal with that. So then we're also going to do, oops, spell that right, it's a little easier. Our synthetic quotient is this 1, -9, and 20. Do you remember what we do with those? So when we were doing synthetic division, we were talking about how those 3 numbers that you're left with are new leading coefficients, so they create something else. So we did have x cubed, so this actually represents 1x squared minus 9x plus 20. So our factored form is x plus 1 times x squared minus 9x plus 20. All right, and then you're going to use a little rhyme for this last part. Step 4, can I factor more? Always ask yourself that. If you're not all the way down to binomials, you can factor more. So step 4, we're going to factor more. You're at a quadratic now, so you know how to factor quadratic, right? So we definitely have our x plus 1. That factor's done. We're going to look and say, all right, I need 2 numbers that add to -9 and multiply to positive 20. Oh, all right, that can factor into x minus 4 times x minus 5. If that whole term is 0, and we look up our instructions say use the rational root theorem, whole number solutions. Yep, we have whole numbers. So what are our zeros? Our zeros are when x equals -1, when x equals 4, when x equals 5. So, crazy process. It's long, and unfortunately it's not even the longest one that we'll do. This is actually a very, very basic one. But 4-step process. After you identify your lead coefficient, your constant, and your degree, step 1, list your possible rational roots using that rational root theorem. Step 2, testing that list with synthetic division. When you get a remainder of 0, you have found yourself a factor. Rewrite it in factored form or the factors that you have. And then step 4, factor some more. Sometimes at step 4, we get to do what we did now. We have a quadratic, pretty easy, deal with it. Sometimes you get to that point and you actually have to repeat all 4 steps again. We'll get there eventually. All right, so let's do one together-ish. You know, by together, I mean I'm going to be pausing and you're going to be trying to do it on your own on a piece of paper and checking in with me. So let's look at number 2.